Hello friends, in this video lecture we will discuss Laplace transform of some basic signals like unit impulse signal, unit step signal and ramp signal. Now first, Laplace transform of unit impulse signal, that is delta ft is equal to delta t. Basic definition: fs is equal to integration xt e to the power minus st dt. Here we put the value of xt is delta t, and the property of impulse function is that delta t minus 0 into any other function xt is equal to xt naught delta t minus t naught. Then we use this property here. Here t naught is equal to 0, therefore e to the power minus s into 0, e to the power minus 0 is equal to 1, and fs becomes minus infinity to infinity delta t dt. This equation is the area of the impulse function. Delta t integration of delta t means area of the impulse function, and we know that the area of the impulse function is always 1. Delta t is equal to area of the impulse function is always 1, therefore integration of 1 dt is always 1. fs, therefore fs is equal to 1. We conclude our solution: the Laplace transform of impulse function is equal to 1. Here 1 is free from s, independent of s. The ROC is entire s plane, because Laplace transform is finite value, always 1. Here is the s plane, and complete s plane everywhere the Laplace transform is finite value. Therefore the ROC is entire s plane. Next, find out the Laplace transform of unit step signal. We all know unit step signal ut is equal to 1 for t is greater than equal to 0, 0 for t is less than 0. Basic definition: fs is equal to integration ut e to the power minus st dt. Here bilateral transform, it convert into unilateral transform by two parts: minus infinity to 0, 0 to infinity. Minus infinity to 0 unit step function is 0, therefore this part is becomes 0, and the right side part is becomes 1. 0 to infinity ut is equal to 1 into e to the power minus st dt. The integration of e to the power minus st is equal to e to the power minus st upon minus s. Therefore we put the limit, lower limit and upper limit, and e to the power minus infinity minus e to the power 0. E to the power minus infinity is equal to 1 upon e to the power infinity is equal to 1 upon infinity is equal to 0. Therefore this part becomes 0, and e to the power 0 is always 1, and minus minus plus 1 by s. fs is equal to 1 by s. Here the shortcut method of find the ROC: ut is equal to 1 into e to the power minus st. The shortcut method, the coefficient of e is real part is minus s, and minus s having real part is minus sigma mod of sigma here real part of coefficient sigma is equal to 0. Sigma is equal to 0. Here this 1 e to the power 0, e to the power coefficient is 0, sigma and 0. and the inequality depends upon a right sided signal or left sided signal. Therefore it is a ut is a right sided signal. Right sided signal means it is greater than sigma greater than 0. Therefore real S is greater than 0 is the ROC. Next, Laplace transform of basic signal, exponential signal. There are 4 types of signal: e to the power minus at ut, minus of e to the power minus at u of minus t, e to the power at u of t, minus of e to the power minus at u of minus t. There are 4 signals. First we take question number 1. ft is equal to e to the power minus at ut. Put the value of ft in the formula: e to the power minus at ut into e to the power minus st. Here minus infinity to 0, this part becomes 0, and 0 to infinity e to the power minus at e to the power minus st dt, and ut becomes 1. Here e to the power minus at minus st, combine it, s plus a into t dt. The integration of e to the power minus s plus a t upon minus s plus a, and put the value of upper limit and lower limit. T is equal to infinity and t is equal to 0. Here minus 1 upon s plus a e to the power minus infinity minus e to the power 0 is equal to e to the power minus infinity is equal to 0, and this value conclude to 1 upon s plus a. ROC, here is the shortcut method of ROC. Finding the ROC, real part of coefficient of 2 in the exponential. Here exponential is e to the power minus at, but e to the power minus at t, the coefficient of t is minus a. The t of coefficient is minus a, sigma and minus a. And how we take the inequality greater than or smaller than, it depend upon the right sided signal or left sided signal. Here this signal is ut, this is a right sided signal. Right sided signal always become greater than, sigma is greater than minus a. Next, Laplace transform of unit ramp signal. Unit ramp signal RT is equal to 0 for t is less than 0, t is t when t is greater than equal to 0. Here RT is equal to, we can rewrite this function RT is equal to t into ut. We know that ut, Laplace transform of ut is 1 by s, and ROC is real s is greater than 0. This equation is proved in previous lecture. Therefore RT, we know that RT is the integration of ut function. RT is the integration of ut function, the relation between RT ramp signal and unit step signal. Therefore we use the property, integration property. Here integration property state that integration, the Laplace transform of integration of any signal is equal to fs upon s. Therefore us is Laplace transform of ut is 1 by s, and divided by s, that is 1 by s square. Therefore Laplace transform of ramp signal is equal to 1 by s square. ROC, here the coefficient of real part, exponential is e to the power 0, and no exponential term, e to the power 0, and the coefficient of t is 0. Therefore real s is greater than 0. Next, Laplace transform of cos omega naught t ut. Here this question is very common question for your exams, and we know that cos omega naught t is equal to 1 by 2 e to the power j omega naught t plus e to the power minus j omega naught t. This is Euler formula, and ft is equal to half this into ut, open this bracket, ft is equal to half e to the power j omega naught t ut plus e to the power minus j omega naught t u of t. Here we know that e to the power minus at ut is equal to Laplace transform of this function is equal to 1 upon s plus a. Here ROC sigma is greater than minus a. Real part of the coefficient a. This is proof in previous lecture. Backside, here we compare this and this equation. A is equal to minus j omega naught. A is equal to minus j omega naught. Therefore, Laplace transform e to the power j omega naught t ut is 1 upon s minus j omega naught t. Here real s is greater than 0. And here e to the power minus j omega naught t, this is 1 upon s plus j omega naught t, real s is greater than 0. We use this equation, we use this formula here, and we combine this function 1 upon 2 1 upon s minus j omega naught t plus 1 upon s j omega naught t, and taking this LCM, this into this upon this j square is equal to minus 1 s naught square plus s square plus omega naught square, 2 is cancel, fs is equal to s upon s square plus omega naught square. And ROC, this is the Laplace transform of cos omega naught t. And ROC, here first function is ROC, real s is greater than 0, and second function is real s is also greater than 0, because e to the power minus j omega naught t, the coefficient of real part, there is no real part, real part is 0, therefore real s is greater than 0, and common part is real ROC sigma is greater than 0. Cos omega naught, Laplace transform of cos omega naught t is equal to s upon s square plus omega naught square, and real s is greater than 0. Similarly, Laplace transform of sin omega naught t ut is equal to, we know that the Euler's formula, sin omega naught t is equal to 1 upon 2j e to the power j omega naught t minus of e to the power minus j omega naught t ut, and open this bracket, and here we use the formula of exponential function e to the power j omega naught t 1 upon s minus j omega naught t. Here we use s plus j omega naught t. Real s is greater than 0 and real s is greater than 0, because exponential function j omega naught t, real part here is 0, the coefficient of t is j omega naught t, and real part is 0, therefore sigma is greater than 0. And further solve this equation, 2j cancel, and finally fs is equal to omega naught upon s square plus omega naught square, and ROC is sigma greater than 0. Very important result. This result is always in your tip for solving the question, and this is the basic signals of Laplace transform. After that, there are some more question finding the Laplace transform. Thank you.